Good day. Welcome to the solutions video for section 5.1b in AP Calculus. We are on page 319 and we're going to be working through these problems listed here. So let's start with number 41. We want to take the derivative of the natural log of x squared. Let's rewrite this as g of x is equal to 2 times the natural log of x, bringing that 2 out front. And then now g prime of x, the derivative of the natural log of x is 1 over x. So it's just 2 times 1 over x. And that is 2 over x. All right, so for number 43, we would have y prime is equal to, this is a chain rule, so 4, bring that out front, 4 times the natural log of x cubed, and then times the derivative of the natural log of x, the inner function, so that's times 1 over x. So I would have 4 times the natural log of x all cubed over x. Okay, for number 45, we want to split this up before we take the derivative. So let's rewrite this as the natural log of x, and it's a product, so plus the natural log, and I'm going to rewrite this radical as x squared minus 1 to the 1/2 power. So now it's easier to take the derivative. Y prime, the derivative of the natural log of x is 1 over x. In fact, let's go ahead and this second part right here, write that as 1/2 times the natural log of x squared minus 1. That'll even make it easier. So I brought that 1/2 out front. Now we'll take the derivative of that. That's going to be 1/2 times 1 over x squared minus 1 times the derivative of this inner function, so times 2x. So the 2's will cancel, and what we're left is 1 over x plus x over x squared minus 1. Now that is the correct answer, and I would accept that on a test. But how do you get the answer in the back of the book? Well, you get a common denominator by multiplying the two denominators together, x times x squared minus 1. That's our new denominator. And then bring x squared minus 1 up to here, multiply it by 1. Bring the x up to the top right, so plus x times x would be x squared. So that's going to be 2x squared minus 1 over x times x squared minus 1. All right. So that's what the book has. So, you know, I have to show you how to do it in case in college you take a multiple choice test and you have to take something like this and put it into a singular expression. I wanted to show you how to get what was in the back of the book. And I'll do that on all of these. I'll let you know if I would accept something a little bit less simplified. All right, number 47. We have f of x is equal to the natural log of x minus the natural log of x squared plus 1. All right, there's nothing really to rewrite here, so we can go straight into taking the derivative. That's going to be 1 over x minus, all right, the derivative of the natural log of x squared plus 1 would be 1 over x squared plus 1 times the derivative of this inner function, 2x. So that's going to be 1 over x minus 2x over x squared plus 1. As far as I am concerned, that's an acceptable answer. However, the book will make this into a singular expression by finding a common denominator. So the common denominator, you take x and multiply it by x squared plus 1. And then you bring the x squared plus 1 and multiply it by 1. So that's x squared plus 1 minus x times 2x, so minus 2x squared. All right, that's going to be 1 minus x squared, right, over x times x squared plus 1. Okay, so if you do that, that would match the back of the book. You need to know how to do that. That's why I'm showing it to you, but I would not count off if you stopped right here. Okay, 49. We have g of t is equal to the natural log of t over t squared. So this one, you really can't rewrite it. You're just going to have to go with the quotient rule here. G prime of t, the bottom, t squared, times the derivative of the top, 1 over t, minus the top, natural log of t, times the derivative of the bottom, 2t. I'm going to put that in parentheses. You're not taking the natural log of it. We'll move it in front in a minute. All over the bottom squared, that would be t to the 4th. All right, so I'm going to clean this up a little bit. I would expect you to clean this up a little bit. So t squared over t will just be t minus 2t natural log of t. I just brought that 2t out front over t to the 4th. I would be fine with that. But we could factor out a t out of the top. So you'd have 1 minus 2 natural log t, if you did that, over t to the 4th. And then we could cancel one of the t's there, make it t cubed. So you'd have 1 minus 2 natural log t over t cubed, which is probably what the back of the book does. But again, so that's the book. I would be okay on a test if you stopped right here. But you do need to know how to do it. I can't, you may have professors in your future that force you to simplify. You need to know how to do it. All right, 51. We have y is equal to the natural log of x squared. All right, we've got a nested log here, don't we? So you could bring the 2 out front here and say that this is the natural log of 2 times the natural log of x. Perfectly fine. You could, if you didn't do that, it still wouldn't be all that hard of a derivative to take. So y prime then would be 1 over 2 times the natural log of x times the derivative of 2 times the natural log of x, which would be 2 over x. The 2's cancel, and this is 1 over, simplifies to 1 over x times the natural log of x. I would expect you to get to this and be able to cancel the 2's. Make sure that you don't write this as natural log of x squared. It's x times the natural log of x, not the value you are taking the natural log of. Okay, so very important there, and I would expect you to be able to get to that. All right, 55. 55, we have the natural log of the square root of 4 plus x squared over x. Now I'm going to go ahead and rewrite this. I'm going to do a lot of rewriting on this one. We would have the numerator be 4 plus x squared to the 1/2 power over x. So let's split all this up. This would be the natural log, of course this is number 55 is f of x is equal to that. Sorry about that. So we'd have f of x is equal to the natural log of 4 plus x squared to the 1/2 power minus, because it's a quotient, the natural log of x. And we can even bring that 1/2 out front, and that will make it a lot easier. 1/2 natural log of 4 plus x squared minus the natural log of x. And now this is not really a difficult derivative to take. You always want to rewrite using the properties of logs. So this is 1/2 times 1 over 4 plus x squared times the derivative of 4 plus x squared. That's 2x minus 1 over x. So the 2's will cancel, and we would have x over 4 plus x squared minus 1 over x. I would accept that. The book will combine these two fractions. So your common denominator would be x times 4 plus x squared. Just multiply those two together. Bring the x up top and multiply it, x squared minus 4 plus x squared in parentheses. All right, the x squareds would then cancel, and you'd have minus 4 over x times 4 plus x squared. That's a singular expression. I'm guessing this is what's in the back of the book. I have not looked at that. But this is great. If you get to that, I'm super happy. If you get to this, I will accept that on the test. All right. All right, great. We're moving right along. Number 59. So 59, we have y equals the natural log of the absolute value of sine x. All right, so y prime would be 1 over sine x times the derivative of sine x, which is cosine x. Well, cosine over sine is just cotangent x. So I would really like you to be able to remember that cosine over sine is cotangent x. So I would, if to get full credit, you need to get to cotangent x. Now, would I count off very much if you left it as cosine over sine? No, just probably 1 point. But I would like you to recognize that. Okay, number 61, we have y is equal to the natural log of the absolute value of cosine x, because you can't take the natural log of a negative, so absolute value cosine x minus 1. Let's rewrite that as the natural log of cosine x minus, because it's a quotient, the natural log of cosine x minus 1. So y prime would be 1 over cosine x times the derivative of cosine x, so times negative sine x, minus 1 over cosine x minus 1 times the derivative of cosine x minus 1, which is also negative sine x. So let's clean that up. That's negative sine x over cosine x. Minus minus makes a plus sine x over cosine x minus 1. You can't really do anything with sine x over cosine x minus 1, but we could say that that is negative tangent x. You could also make them into a singular expression. I really like this better. Get that tangent x in there, that negative tangent x. All right, only 2 more to go. Hope you enjoy these, just kind of very mechanical kind of homework. Just know the rule and work the rule. So 64, we have y is equal to the natural log of the square root of 1 plus sine squared x. Okay, let's rewrite that as the natural log of 1 plus, I'm going to rewrite it as sine x all squared to the 1/2 power. And then I'm going to bring that 1/2 power out front before I take the derivative. All right, now let's take the derivative. So it's going to be 1/2, that coefficient out front, times 1 over 1 plus, I'll go ahead and call it sine squared x, times the derivative of 1 plus sine x all squared. That would be 2 times sine x to the first power times the derivative of sine x, which is cosine x. Okay, the 2's will cancel. So I would have sine x cosine x over 1 plus sine squared x. All right, and I would certainly let you stop there. But yeah, that's great. We got one more to go. 69. So 69, we have a relation. So we're going to have to use implicit differentiation here. We have x squared minus 3 natural log y plus y squared is equal to 10. And we want to take the derivative of that with respect to x. So the derivative of x squared with respect to x is just 2x. Now we have a y involved, so this is going to be minus 3 times 1 over y. So that would be 3 over y times the derivative of y, which is dy dx. So you'll have a dy dx anytime there's a y. All right, plus 2y dy dx. So we're taking the derivative of this term with respect to x is equal to 0. Now let's get all the dy dx terms. I'm going to put the positive one first, so I would have 2y dy dx minus 3 over y dy dx. So I just flip those two, equal to negative 2x. And let's factor out a dy dx, be 2y minus 3 over y equals negative 2x. All right, so there's several ways we could tackle this, but dy dx is negative 2x over 2y minus 3 over y. Now, I would accept that. Okay, but I want you to know the easiest way to get rid of this compound fraction here. Let's multiply it by a clever version of 1. So how about y over y? That would get rid of that y on the bottom. So this is negative 2xy over 2y squared minus 3. All right, so that's the best way to do it, but I would not count off on a test because the class isn't about algebraic simplification. It's about getting the derivative right. And I want you to get rid of all negative exponents and do any easy coefficients, simplify those. But I would accept this. But your book is going to go a little bit further in order to get it into a singular fraction. All right, that does it for this video. I hope that helped you, and I will talk to you on the next one.